Right. So when you come up with this, the second order differential equations, I told you the last session, there were two part of a solution is there. The first part is a complementary function, and the one is particular integral. So when you get this kind of like this, what do you call that? If the differential equation is in this kind of format, so if it is like a d squared y by dx squared plus b dy by dx plus c is equals to 0. This kind of equations we call it as homogeneous differential equations. Homogeneous differential equations. For this one, you have only a complementary function with it. So you can, the solution is only complementary function, right? Okay. So if it comes with a d squared y by dx squared plus b dy by dx plus c is equals to another function with a gx. This is a non-homogeneous differential equation. So in this case, it is the solution become a complementary function of a, it's a complementary function plus it is addition of a particular integral with it. Right. So today our topic is to understand about how to find the particular integral for non-homogeneous differential equation. Usually to find the particular integral, this is the fact where we use it. Right. Right. So in this case, usually we get just like a small function with that. Let particular integral is become just fx scale. Then you can say the form of fx. So you can say what the different kinds of particular integrals can come across different kind of extents. The forms we are learning few forms of it with a form of fx. Yeah. If the form of fx it can be p. If it's so, we will consider the particular integrals. Form of particular integral for this kind of it. If you get a particular integral, it just like a turn up into a constant of lambda. Right. If the form of fx become p plus qx, you can get this lambda plus, this is turn up to mu x, where this lambda and mu are the constants. If it is a quadratic one, p plus qx plus rx squared. So this is just like lambda plus mu x plus, when you're working out with the gamma, sorry, you'll understand that how it comes over here. If it is turned up to p e to the power qx, if this particular integral is like this, the answer become lambda e to the power mu x. This is the answer of particular integral you can obtain for different kinds of aspects, right? Okay. So if it is turned up into this way, p cos a theta ax or theta whatever q sine b theta. If it's so, this one turn up into the lambda cos a theta plus mu sine b theta. Here the a and b would be the same, right? Okay. Now this is the formats where we can see for this particular integral, and these are the solutions we can expect for a particular integral. But just looking in this graph, you won't understand what I mean. But with the time, when you are working out the question, you will understand that how does this come. So basically, we should have the idea, the type of particular integral relative with the fx in a second order differential equation, which is a non-homogeneous differential equation. So this table is kind of important for you, and it's a kind of a guidance for you to understand how to form a particular integral with it. Right. Okay. Let's go ahead a little bit further from a question. Let's try to understand. Right. Okay. Then they have given the question. It's just like this. So What they mean is, but it's just a question like this. They have given the second order differential equation. So this one, my end one. They have given d squared y by dx squared plus minus 5 dy by dx plus 6y equals to fx. Right. Then they have given the first part of it, fx. We need to find the particular integral. Find particular integral. This is a way of doing it. Right. Initially, we know that according to this one, fx equals to 3. That is the first type of the graph. This type of a graph. This kind of a graph. Right. Then what you can understand is, if it's so, we have to select this particular integral in this format. Then we will get, we will get the particular integral as lambda. That means we will consider y is equals to lambda. Let. It's the way of doing this question. Let. If it's so, what you can understand is, dy by dx is equals to how much if you differentiate lambda? Answer is 0. D squared y by dx squared is equals to how much? That one also equals to lambda. Then we can replace into this equation. Then you will get the equation is d squared y by dx squared minus 5 dy by dx plus 6y is equals to 3. This is the different. This is the equation where we need to solve. Since this is just like a constant of 3 over here, we just get it as lambda. Then over here you can say this is 0 minus 5 into 0 plus 6 into lambda is equals to 3. With that, what you can obtain is, you can say lambda is equals to 1 over 2. Lambda is equals to 1 over 2. Therefore, you can say particular integral. Particular integral is equals to 1 over 2. Right? Okay. Then I'll just break this question into this pi particular integral. We will try to find out the complementary function and the total solution. From the same question, I will show you how to get these facts, right? Particular integral, how to find it, complementary function, how to find it, and the how to find the total solution for that. Right? When you find this total solution, now you can understand that here, then to find the complementary function, this is the particular integral. Now I'm going to find the complementary function. Complementary function is, this is d squared y by dx squared minus 5 dy by dx plus 6y. Therefore, I will consider to find the complementary function, I will get that y equals to e to the power mx. I'll get y equals to e to the power mx. That is a fact where we use to find the complementary function. Right? Or other than that, straightforward I can write this without doing all of these steps. You can just write this is m squared minus 5m plus 6 is equals to 0. Okay, so this is the base. What we do here is we just get it as y equals to e to the power mx and do the differentiation, and we got it. That's the format where we have used in the last, we have already learned how to do it in the last section today. So in that you get the answers for m. M is equals to m is equals to plus 2 and m is equals to plus 3. These are the answers where we obtain for m for this answer. So with that, we can perform the equation. It's in form of what do you call that? You get two different solutions. Since you have two different solutions for this, simply we can write the answer in form of, this is not just a, like there are three conditions we have already learned. One condition is if you have two solutions, and the other condition is if you have one solution, and third condition is if you get if you don't have different kind of different kind of solutions, means like no real solutions. So in this case you can say complementary function is equals to, this is a e to the power 2x plus b e to the power 3x. This should be the complementary function for that. Right. Then we can find the total solution for it. Then you can write the total solution. Total solution become this way. Y equals to, the complementary part is a e to the power 2x plus b e to the power 2x, and this is the complementary function plus the particular solution. Particular integral. Particular integral become half. This should be a total solution. Later on we learn how to find the value for a and b. We need to find the value for a and b, right? Okay. Then in part B, when you are referring to part B, they have given this equation. In the same question, they have given the equation this format. D squared y by dx squared plus, sorry, this is minus 5 dy by dx plus 6y is equals to fx. Now they ask you to replace it 2x. Initially, they need to find the complementary, particular integral. Part 1, I just make it as part B, complementary function, part C, total solution. Total solution, let's see how to do this. But in this case, initially same fact we will consider, y equals to 2x. Y equals to 2x. To find the particular integral, what you need to do is, if it is just like a p plus cube x format, we'll just put it as lambda plus mu x. Here you get only 2x, but we need to work in this format. Then we have to get this one as, let y equals to lambda plus mu x. Though you don't have another constant over here, but we need to use this one format. So from here you can say dy by dx is equals to mu. D squared y by dx squared is equals to 0. Therefore, you can write from this equation 0 minus 5 times of mu plus 6 times of lambda plus mu x is equals to 2x. Then you can say minus 5 mu plus 6 lambda plus 6 mu x is equals to 2x. From this equation, what you can obtain is, if you equate the coefficients of x. The coefficients of x in this side is 6 mu, whereas coefficient of x in this side is 2. Therefore, mu turn up into 1 over 3. Then we will consider the constants. The left hand side, this side, the constant is 6 lambda. Sorry, 6 lambda minus 5 mu. And this side is, there is no constant, because this is just like no constant over here. So now you know that 6 lambda minus 5 over 3 is equals to 0. With that you can say lambda is equals to 5 over 18. Then you can write the particular integral. Particular integral is mu is 1 over 3, 1 over 3x plus lambda is 5 over 18. Now only Fadil is coming. Right, okay. Then or from the first question, we have already learned how to find the particular integral, complementary function. Complementary function is this bit. I just little bit of make it little bit smaller, then you can see the entire stuff. So you can write then for this question, the complementary function, same thing, because the same function over here. CF is equals to the value you get it is a2x b2 b. It's not 2x, it's just 3x. This is 3 a2x b3x. A e to the power 2x plus b e to the power 3x. Then we can find the total solution. The total solution become y equals to a e to the power 2x plus b e to the power 3x, and the particular integral is the complementary function in this bit. Particular integral is put a 1 over 3x plus 5 over 18. That's a way of getting this answer. Right. That's, yeah. Right. Okay. Then let's come on to the next question. Yeah, I'll start a new page. Then it will be easier for us to do it. Then part C. In part C, they have given d squared y by dx squared minus 5 dy by dx plus 6y is equals to, this is an non-homogeneous equation. Third case they are referring is 3x squared. 3x squared, right? Then we have to use the third format of it. But I just, if I just go to this table, this, if it is a quadratic equation, we have to use this is as a particular integral format. Then use I will get this equation in this format. Get, let y equals to lambda x squared plus we will get mu x plus gamma, right? If it is so, you can say dy by dx. dy by dx is 2 lambda x plus mu. Then d squared y by dx squared is equals to 2 lambda. Then if you substitute over here, you get the answer 2 lambda minus 5 times of yeah, 5 times of 2 lambda x plus mu plus 6 times of y. Y become lambda x squared plus mu x plus gamma is equals to, you can say 3x squared. Then if I just expand this bracket, so it will turn up to 6 lambda x squared. X terms are 6 mu and minus 10 lambda x. So it's turn up to 6 mu x terms, 6 mu over here from here, minus 10 lambda x, minus 10 lambda x. Then you get the constant terms. The constant terms are 2 lambda over here, minus 10 mu, 10 mu, and the other one is 6 gamma. 6 gamma is equals to 3x squared, right? Okay. Now what you need to do is, initially we need to identify the these values for 6 lambda, mu, and gamma. So initially I'll equate the coefficient of x squared. Then what do you get? 6 lambda is equals to 3. From here you get the value lambda is equals to how much? 1 over 2, right? Okay. Then I'll consider the coefficients of x. So here the coefficients of x become 6 mu. This is 6, but I guess let's bracket 6 mu minus 10 lambda is equal to, here there is no x terms, but it's turn up to 0. Then we know that lambda is half, therefore 6 mu minus 5. 10 into half is minus 5. So with that you can get the answer mu is equals to 5 over 6. Then I'll consider the constant terms. The constant terms here, this is 2 lambda minus 10 mu plus 6 gamma is equals to 0, because there is no constant terms over here. So with that, what you can get is this way. Lambda is half. 2 into half is 1. 10 mu. 10 into 5 divided by 6. That is minus 50 over 6 plus 6 gamma is equals to 0. When you simplify this, you will understand that yeah, 1 minus, just check with these calculations. Other than the technique is same. That is yeah, 1 minus 50 over 6 is minus 22 over 3. If you go to the other side, is plus 22 over 3 divided by 6. It is turned up to minus 11 over 9. Gamma become minus 11 over 9. That's the answer where you need to get for gamma. Right. Hopefully, let's check with it. This is 1 over 2x and gamma is 5 over 6 and minimum just a small error came. This is, yeah, 6 mu minus 10 lambda. Yes. If you go ahead with the second differentiation with it, 2 lambda minus, there was an error came over here with it. Just let's check with the constant terms with it. Minus, here there's a mistake. Mm, the mistake is if you consider the constant terms, but this is 5 mu. I think this is not minus 10 mu. This is turned up to minus 5 mu. This is wrong. I just use a different color to show the correction. This is minus 5 mu. Yeah, that's one. So in this case, if you do the correction, this should be minus 5 mu. But here it should be corrected. This is minus 5 mu. Sorry. Minus 5 mu. So then it's turned up into minus 5, minus 1. Mu is, we already got the mu value for 5 over 6. Minus 25 over 6. Minus 25 over 6. 1 minus 25 over 6. Just, it's 19 over 6. 19 over 36. Then it's turned up to 19 over 36, right? Okay. Now that, then you can write the particular integral with it. Then you can write, I'll just, now the answer become, you can write particular integral is equals to, according to this one, lambda. Lambda is 1 over 2x squared. 1 over 2x squared. Mu is plus 5 over 6x plus gamma. Gamma is 19 over 36. Then there's a particular integral. Then complementary function, we already knew from the first part of the questions, that is 2 and 3. Yeah. A e to the power 3x plus b e to the power 2x. This is a complementary function. Therefore, you can find the total solution for this. Total solution, then y equals to a e to the power 3x plus b e to the power 2x. This is a complementary function plus particular integral 1 over 2 x squared plus 5 over 6x plus 19 over 36 would be the total solution for this kind of a question. That's a way of doing this kind of situation, right? Okay, I'll just make it small, little bit small. Then if I go to the first question, part A, this was the total solution over here, just this part of it. So you can just refer with that particular integral plus complementary function. And this is the second part of the answer. And over here, you can see that's the third part of the answer. Right? That's how it comes. Right? Then let's go to the next part of the question. In this next part of the question, what they say is, it's just like this. Right. It's they ask us to show for e to the power 2x. That is part D. The question is d squared y by dx squared minus 5 dy by dx plus 6y is equals to e to the power x. Just e to the power x they have given. Yeah. I just make it as e to the power 2x. E to the power 2x. If I make just to this 2x, 2x. Then if it is so, what you can get here is initially we will get let to get the complementary function, sorry, particular integral, y equals to lambda e to the power mu x. That's the format where we use to get the value for that, right? Okay. Then if you do it, what do you get? Dy by dx. Dy by dx is how much? Lambda mu e to the power mu x. Plus, again, if you go to the second differentiation, d squared y by dx squared, that is lambda mu squared e to the power mu x. That those are the differentiation formats where you can obtain for as a particular integral.
So the form, isn't it e to the power
Yeah.
kx?
Yes. There's a issue over here. See, if it is, yeah, what is it?
So form of particular integral, isn't it e to the power kx or e to the power mu x?
But it's just not because those are constants, so you can put anywhere
Okay.
figure somewhere like that. So it doesn't make a big issue, right? Okay.
Okay.
Then like this has become a little bit of complex, but anyway we'll try to do this. So anyway, but then if you do this, d squared by dx, so it is turn up to lambda mu squared e to the power mu x minus 5 dy by dx is lambda mu e to the power mu x plus 6 lambda e to the power mu x is equals to e to the power 2x. Then you can say e to the power mu x, I can take it out from the entire equation. So it will turn up to lambda mu squared minus 5 lambda mu plus 6 lambda is equals to e to the power 2x. So simply from this equation, if you equate the coefficients of e to the, so you can say mu is equals to 2. Mu is equals to 2, right? Then what you can get here is, then you know that if I just take like this fact of it, this, if this is two facts are constant, lambda mu squared minus 5 lambda mu plus 6 lambda, you can equate into 1, because I will just write this one as, because the same e to the power function is, if it is the same thing, you just write this one is into 1, right? Okay. Then with this information, what you can get with it? Then we know that mu equals to 2. So it is turn up to 2 lambda. Sorry, not 2, just it's 4 lambda. 4 lambda and mu is 2 means minus 10 lambda plus 6 lambda is equals to 1. So for this case, what you can understand is, so 0 is equals to 1. What was the problem over here? The problem over here is there is no such lambda exists for this kind of situations. There is no lambda exists for, because you get an answer like 0 equals to 1. For this kind of situations, straightforward, we cannot use this format for that as an answer, because the lambda is not existing for this kind of situation. This is not valid. Not valid. With this, we will get the fact of y equals to e to the power mu x. We will get only this part of it, because the lambda does not exist over here. That's the fact we have to understand in this question. Then what you can write over here, like if you do this, then you will turn up to dy by dx is equals to mu e to the power mu x. Let's do this and see whether d squared y by dx squared is equals to mu squared e to the power mu x. Then let's see how it comes. Then it's a turn up to mu squared e to the power mu x minus 5 mu e to the power mu x plus 6 e to the power mu x is equals to e to the power 2x. Let's do this and see. Mu squared minus 5 mu plus 6 into e to the power mu x is equals to e to the power 2x. So with this fact, we can get mu is equals to 2. Then whether it satisfies this condition, let's turn up to 2 squared is 4 minus 5 into 2 is 10 plus 6. That one also is equals to 0. That's correct. So with that, what you can get here is then mu equals to 2. So with that, you can write the particular integral in this format. Particular integral is equals to lambda katna y is, sorry, particular integral is e to the power just 2x. You can write in that format, right? So there is a little bit of advancement of this question. I just changed a little bit of this the question given in the book. Then we'll come up with the question which is available in the book, and let's try to do this with it. Yeah. Yeah. So if it is a question like this, but d squared y by dx squared minus 5 dy by dx plus 6y is equal to, just they have given just e to the power x. If it is just e to the power x, you can write the what you call that particular integral substitution as y equals to e to the power lambda x with it, e to the power lambda x. Then dy by dx become lambda e to the power lambda x. And second differentiation is lambda squared e to the power lambda x with it. So in this case, you can say lambda squared e to the power lambda x minus 5. This is lambda squared e to the power this 5 lambda e to the power lambda
Sir,
x. Yeah, can what is it? 6.
sir, y should be lambda e to the power x, no?
Which part with it? Here.
Why the particular integral, shouldn't it be lambda e to the power x?
Ah, no, no, yes, yes. So we can just get it in that one even, doesn't matter. Make it in, yeah, that's it. Sorry, I just made a mistake. This should be lambda e to the power x. Then you can say y equals to lambda e to the power is e to the power x. You can just write like this. So that's great. Okay. Then you can say dy by dx. How do you get the dy by dx? So it's just it's a constant over here. So if you do this differentiation, second differentiation also lambda e to the power x. Sorry, first differentiation. Second differentiation also the same thing, because you know that lambda is just a constant. Differentiation of e to the power x is the what do you call that, e to the power x itself. So this should be lambda, right? Okay. Then you can say this is lambda e to the power x minus 5 lambda e to the power x plus 6 lambda e to the power x is equals to e to the power x. That what you can write over here. Now it's becoming a little bit of the worst situation.
6 lambda. So
Yes,
6 lambda e to the power x.
6 e lambda e to the power x. Here. There are 6 plus 7, it's 2 lambda e to the power x become e to the power x. So in that case, lambda become half. Yeah, lambda become half. Therefore, you can write the particular integral. Particular integral is equals to lambda is half according to this fact where we get it. So it should turn up to half e to the power x would be the particular integral. Complementary function, we already got it. That is a e to the power 2x plus b e to the power 3x. Therefore, you can find the total solution with it. Total solution is y equals to a e to the power 2x plus b e to the power 3x plus half e to the power x. That's the answer for that. That's the way of doing this question. Yes. Then, yeah, that's what you can do it. So if the trigonometric functions involved with this, right? The next question they are referring is just like this. I'm using a new page because then it would be kind of easier for you to finish the one full question in one page. Is the answer for that question today? Is the way of getting this right. Then if you come over here, right. The question is today the same question. d squared y by dx squared plus, sorry, minus 5 dy by dx plus 6y is equals to, they ask us to get 13 sine 3x. 13 sine 3x. Then we will get the function let y equals to, we will get some kind of a constant. Can you get, you can put any constants you like. I just put lambda e to the power, sorry, lambda sine 3x plus mu cos 3x. Because if the angle is same, you have to put the same angle. Then you can write dy by dx. If you differentiate it, you get 3 lambda cos 3x minus 3 mu sine 3x. Then if you do the second differentiation, it's turn up to minus 9 lambda sine 3x. Then if it is turned up to minus 9 mu cos 3x, then you can write minus 9 lambda sine 3x minus 9 mu cos 3x minus 5 times of 3 lambda cos 3x minus 3 mu sine 3x plus 6 lambda sine 3x plus mu cos 3x is equals to 13 sine 3x. So if you do this, if I get the sine 3x terms, minus 9 lambda plus 15 mu plus 6 lambda. And if you get the cos x terms, cos 3x terms, cos 3x terms refer to minus 9 mu minus 15 lambda plus 6 mu. This is equals to 13 sine 3x. Then if I equate the sine 3x coefficients, so you can say this is minus 3 lambda plus 15 mu is equals to 13. This is my first equation. Then if you get cos 3x terms, you can say minus 3 mu, sorry, minus 15 lambda minus 3 mu is equals to 0. There is no cos x terms over there, right? With this information, we can get the value for lambda and mu. Minus 3 and 15 and 13 are the coefficients, and over here minus 15, minus 3 and 0 is the other factor. So you get the answer lambda equals to 1 over 6 and mu is equals to, sorry, minus 1 over 6 and 5 over 6. This is minus 1 over 6 and 5 over 6, right? So with this fact, you can find the particular integral. So you can say particular integral is equals to lambda is minus 1 over 6 sine 3x plus 5 over 6 cos 3x, right? Then you can write the complementary function is same thing, a e to the power 2x plus b e to the power 3x. Therefore, you can write the total solution as a e to the power 2x plus b e to the power 3x. The complementary function, sorry, particular integral is 1 over 6 sine 3x plus 5 over 6 cos 3x is the answer for that. Okay, that's a way of doing this question, right? Okay. Yeah, that's a way of doing this kind of a question. Right. When you come up with this kind of situation, yeah, not this one. This kind of situation, there is another alternative fact where we can do this for this question. Okay, because like if you get another constant over here, if this does not works, for this particular integral, we can use another technique. This is a second method where we can do so. You can use both techniques and get the different aspect of answer, but the final answer becomes the same thing. It doesn't make a significant difference because when you substitute the figures, you get the same thing. So for this kind of situations, Pute, we will get this kind of it. The question is, Pute, d squared y by dx squared minus 5 dy by dx plus 6y is equals to, this is a question, equals to e to the power 2x. E to the power 2x. The best solution is if that if this from here, if it does not works in this situation, because like you get 0 equals to 1, and here also this answer is not stable with it, because here the answer is there is one only at a one condition only we can equate. So this part is turned up to 0 only, you can equate this two. Other than that, this is not a much of a reasonable answer. Over here, this one also not working, because again this is not 0, this is 1. Again turned up to 0 equals to 1. So it's not literally work. So this method also not valid, not valid. So this is not function. So in this kind of situations, we can use this kind of a technique. We'll get y equals to, we just put the usual substitution. We put yeah, what do you call that? Lambda e to the power mu x. So here this function is 2. So if it is 2, just like the branch is 2x here. Then I'll use another technique for this. I'll just use this equation, this format with it. Lambda x e to the power 2x. That one you will use if this is does not work. If this does not work, only we can use this technique, right? So with that you can write dy by dx. First differentiation. First differentiation is we can use the product rule for that. So it will obtain you, first keep lambda x and differentiate e to the power 2x. If you differentiate e to the power 2x, 2 e to the power 2x. Plus keep e to the power 2x and differentiate lambda x. It's turned up to lambda. So this final answer is 2 lambda x e to the power 2x plus lambda e to the power 2x, right? Then if you go into the second differentiation, dx squared. So this is turned up to, if you do it again we are differentiating this bit of it. That is similar to lambda, twice of this amount. So it's turned up to twice of 2 lambda x e to the power 2x plus lambda e to the power 2x plus, if you differentiate this bit, is turned up to 2 lambda e to the power 2x. So 4 lambda x. So this is turned up to 4 lambda x e to the power 2x. Over here 2, it's turned up to 4 lambda e to the power 2x. Right. Then what you can get here is, then if you substitute into this one, what do you get? 4 lambda x e to the power 2x plus 4 lambda e to the power 2x minus 5 times of this bit. 2 lambda x e to the power 2x plus lambda e to the power 2x plus 6y. Y is lambda x e to the power 2x is equals to e to the power 2x. So from this information, what you can get here is, from here, if you simplify this fact of it. So if you just do this simplification, you can just equate these facts like this. 4 lambda x e to the power 2x minus 10 lambda x. So you can remove this e to the power 2x term from all of these terms, but it's turned up to 4 lambda x plus 4 lambda minus 10 lambda x minus 5 lambda plus 6 lambda x is equals to e to the power, e to the power 2x terms cancel, so it turned up to 1. So if you just get the x terms, it's turned up to 10 lambda x. These two terms, these three terms get cancelled. It's turned up to minus lambda equals to 1. So therefore lambda equals to how much? Lambda is equals to 1 over here, minus 1 over here. So with that you can find the particular integral is equals to, make it with here, y equals to minus x e to the power 2x would be the particular integral for that. With that you can find the complementary function and you can do this question. So so in that kind of situations, this is the way of approximations was a different kind of alterations we have to do for if you need to really, if you really need to go ahead with this kind of questions with it. Hopefully you understand. So if I just go ahead with the answers for the first couple of questions where we do it today. So anyway, this is the particular, sorry, the second order differential equation. So it has two solutions, complementary function and a particular integral. So the particular integral, the fact we have learned today. In the previous session, we did how to do the complementary function for this. So with this particular integrals, so different aspect of situations where we have different kind of particular integrals. So these are the modules. If this is just like a constant, we use this one with it. So the same condition, but we practiced over if it is 3, we just get a lambda, which is just a constant, right? Then the second situation we discussed today is if it is just 2x term. So according to the same relationship, we just get this lambda plus mu x and then we get this answer. Then for third one is if it is a quadratic one, we had to use the lambda x squared plus mu x plus gamma according to the first table figures where we have already given. If it is exponential, we can get this kind of situation. So if it is not working, we can put another constant at front end. You can do this question. That's a situation where we did. And this is just like a normal exponential fact. And if it is a trigonometric fact, we use this kind of relationships, right? That's a way of doing this kind of question.